Welcome students again into the chemistry class. Today we are learning the 11th science chapter number 10, state of matter. Now the gaseous state we already learned, and from the last lecture we are learning about the liquid state. Now in last lecture I told you why the liquid take the shape of that container in which they are placed, how the forces, that is the intermolecular forces of attraction between the liquid molecules are intermediate in the solids and gases intermolecular forces. And also I told you about the common properties of the liquid and the differentiate properties of the different liquids. Now, these properties we are learning now are the quantitative property. That means we can measure that properties in a definite unit. Now, in last lecture I told you about that of the vapor pressure of the liquids. Now the pressure exerted by the vapors of the liquids on the surface of that liquid at equilibrium, when the rate of vaporization and rate of condensation becomes equal, at that time the pressure exerted on the surface of the liquid is called as the surface vapor pressure. Now today we are learning the second property of the liquid, that is the surface tension. Now, as the name suggests, it is the force on the surface. Now, tension is the force. Now, see here, in this figure, I take suppose liquid is there in a beaker. Now, if any molecule is present in the bulk of the liquid, that molecule which is present in the bulk of the liquid can attracted by another molecules in all the directions. That means what? The molecule in the bulk have the balanced force, and due to that the force acting on that molecule which are present in the bulk is zero, because this molecule is attracted by all the direction. But the molecule which are present on the surface, now these molecules are attracted by the liquid molecules only from the bulk of the liquid and from the surface of the liquid, the molecules which are present on the surface. That means on this space, that is the empty space above the liquid, there is no attractive forces on that molecules on the surface. That means the molecules at the surface is in the imbalanced force. Now due to that imbalanced force, the molecules or the liquid tends to take that is the less surface area. That means that is why the liquid take a shape which is spherical. When we take a drop of the liquid, do you know why the drop of the liquid always have the spherical shape? They do not have the conical shape or cuboidal shape or any other different shape, but they always have the spherical shape of any liquid drop, always have the spherical shape. And if we place the liquid drop on any, that is the solid surface, the shape of the liquid drop is hemispherical or semi-spherical. Now this is due to the surface tension. This property is due to the surface tension. Again, the capillary action which is present in the capillaries of the tallest trees, the groundwater can carry by the tissues of these plants up to the top of the plant, and this is due to the capillary action, and capillary action is also due to the surface tension. Remember that. And therefore the drop of the liquid take a spherical shape because the liquids have a tendency to minimize their surface area due to this surface tension or imbalanced force on that molecules which are present on the surface. So the liquid always have the spherical shape. Droplet of the liquid always have the spherical shape because the molecules which are present on the surface, now there is the surface tension, and due to that surface tension they have a tendency to minimize their shape, and therefore the liquid droplets have the spherical shape. Now what is the actual definition of this surface tension? Now see here definition. The force acting per unit length perpendicular to the line drawn on the surface of the liquid is called the surface tension. Now, if we draw a line on the surface of the liquid, then the force acting per length, suppose 1 millimeter, 1 centimeter, in this way, the force acting per length, the force acting per unit length perpendicular to the line drawn on the surface of the liquid is called as the surface tension. Now this is the line which is perpendicular, the unit length which is drawn perpendicular on the surface of the liquid. Now the force acting per unit length perpendicular to the surface of the liquid is called as the surface tension. So surface tension is on the whole drop on the surface of the drop of the liquid, and that is why due to that perpendicular force which is acting on the line drawn on the surface of the liquid, this is called as the surface tension. And surface of the liquid acts as the stretched membrane. Due to that, why the surface of the liquid acts as the stretched membrane? Due to the surface tension. So the always the surface of the liquid acts as the stretched membrane. The particles in the bulb of the liquid is uniformly attracted in all directions, and the net force acting on the molecule which is present inside the bulb is always 0. But the molecules on the surface experience a net attractive force towards the interior of the liquid. There is always net attractive force toward the interior of the liquid. Therefore, the surface of the liquid acts as the stretched membrane, and these forces are imbalanced forces. And so the liquid have a tendency to minimize their surface area, and that is why the shape of the liquid drop is always spherical. And surface tension is a temperature dependent property. As temperature increases, surface tension decreases, because as temperature increases, kinetic energy also increases, and the molecules, due to the kinetic energy, the molecules are separated, and therefore as the kinetic energy increases, surface tension decreases. Remember that. So surface tension is a temperature dependent property. It is a temperature dependent property. When attractive forces are large, surface tension is also large. That means when the attractive forces are large, when temperature is less or minimum. But as temperature increases, attractive forces decreases, kinetic energy increases, and due to that, what happened? Due to the decrease in the attractive forces, surface tension also decreases. So surface tension is always maximum when there is strong attractive forces. So when the attractive forces are large, surface tension is also large. But surface tension decreases as the temperature increases. With increase in temperature, of the molecules, the kinetic energy of that molecules increases, so intermolecular forces decreases, and that is why the surface tension also there decreases. As the intermolecular forces decreases, surface tension decreases. And capillary rise of the liquid is also the property or phenomena which is often due to the surface tension. Now let us learn the unit of the measurement of this surface tension and which are the factors which affects on the surface tension. Now let us learn about that. Now let us learn the unit of surface tension. Now as we know that the surface tension is nothing but it is the force attracted or force acting on the surface which is perpendicular, that is the length, unit length, the force acting per unit length on the line of the surface which is perpendicular to the surface. Now see here, as it is the force per unit length, so the unit of surface tension, that is surface tension, is measured in the SI unit, and that SI unit is Newton per meter. Now Newton is the unit of the force and Newton per meter means length. So Newton per meter is the SI unit of the measurement of the surface tension, and this is denoted by the Greek letter gamma. So gamma or Newton per meter is the SI unit of the surface tension. Now let us learn the applications of this surface tension. There are two main major applications of the surface tension. The first one is the cleaning action of soap and detergents. Now why the soap and detergents cleans the oily stain, even the oily stain on the fabrics? Now this is due to the this cleaning action of soap and detergents is only due to the surface tension. Now cleaning action of soap and detergents is due to the lowering of interfacial tension. The interfacial tensions between the water and oil molecule get lower due to these soap and detergents, and that is why what happened. And as the soaps and detergents cleaning action is due to the lowering of interfacial tension between the water and oily substance, due to the lower surface tension, as the surface tension becomes lower, that is interfacial tension becomes lower, and due to the lower surface tension, what happened? The soap solution penetrate into the fibers and surrounds the oily substance or oily drop and washes it away. Due to the lowering of the surface tension, these soap or detergents liquid penetrate into the fabrics, and due to that penetration, it surrounds the oily substance or oily stain and washes away it from that of the fabrics. So these soaps and detergents lower the interfacial tension, that is the surface tension of oil and water, and due to that they penetrate easily, this solution penetrate easily into the fabrics and it wash away the oily stain or oily substance. Now second is the very useful application of this surface tension is that efficiency of the toothpaste as well as mouth washes, nasal drops, they are very effectively penetrate, and this efficiency of the toothpaste, mouthwash and nasal drops is partly due to the presence of the substance having lower surface tension. In that toothpaste and in nasal drops and in the mouthwashes, there are such substances are present which have the lower surface tension, and due to that what happened? Due to the lower surface tension, This increases the efficiency of the penetrating action of these toothpaste, mouthwash and nasal drops, and due to that, that's why they penetrate easily. Now let us learn the third main property of the liquid again. Now this is also the quantitative property, characteristic property of the liquid, that is the viscosity. You may learn about the viscous liquid. Now we know that the gum and that is the honey, these are the viscous liquid. But water, petrol, these are the very less viscous liquid, because this is due to the viscosity property. Now what is viscosity? We know that the fluid or liquids are always in a flow motion, and that is the layer of the liquid which is on that surface, that is the lower layer of the liquid, that flow with a less rate than the layers which are always on the upper side, and that is why there is always such curve shape to the flowing liquid when they goes away. And this viscosity is nothing but it is the force of friction. So what is the definition of viscosity? Viscosity is the force of friction between the successive layers. Two successive layers flow, and due to that there is the force of friction between the successive layers, and the force of friction between the successive layers of the flowing liquid is called viscosity. So the force of friction between the successive layers of the flowing liquid is called as the viscosity. Now liquids or fluids have a tendency to flow, we know that, and viscosity measures the magnitude of internal friction. Now this viscosity always measures the value or magnitude of internal friction in the liquid to flow as measured by force per unit area, resisting uniform flow of the liquid. Now the friction, due to the friction there is the resistance between the resistance in the flow of the liquid, and that resistance is nothing but, that is the friction force is nothing but the force of friction between the successive layers in the liquid, flowing liquid, is called as the viscosity. Now different layers of the liquid which is flow with different velocity. Now I told you the layer which is the lower layer just in contact with that of the solid surface on which the liquid is flowing. This is the very stationary type of the layer. It have very less velocity. But the layer above it somewhat more velocity. Again the layer above that somewhat more velocity. So the different layers of the flowing liquid have a different velocity. And this is called the laminar flow. That is the laminar flow. Now in this way, the flow of the liquid is always as that of the laminar flow. It flow in this way. That means somewhat the upper layers goes very fast than the lower layer, and because their velocity is more than the lower layer. So this flow is called as that is laminar flow. Now let us learn more about this viscosity, how there is the figure for the viscosity. Now let us learn about more that of the viscosity. Now here is the figure which is the cross section of tube or pipe through which a liquid is flowing. Now these are the different layers of the liquid. Now the layer which is at the center of this have more value of the velocity. That means the middle layer or central layer flow with greater velocity than the layers which are near to the wall of that pipe or tube. Now these are somewhat, because their velocity as they go away from the center, their velocity decreases by the value dv. and dV and dV. That means the layers which are nearer or just attached to the wall of the pipe are having very less velocity. That means they are the stationary layers. Now this is the figure of laminar flow of liquid through a tube or pipe. Now see here the figure, laminar flow of liquid through a tube or pipe. Now this is the center of the tube. Now we know that the layers of the molecules in the intermediate contact of a fixed surface remain stationary. I told you that the layer which is on the surface, the first layer, this is the stationary layer which is just in contact with the fixed surface, remains stationary. And that is why they flow with a less velocity. The layers which are near to the fixed surface flow with a less velocity because they are stationary, and the subsequent layers slip over one another. But if there are strong intermolecular forces are present into that liquid, then that strong intermolecular forces disturb or abstract or resist the layers from slipping over one another. And due to that, what happened? There is the friction between the two successive layers. So, strong intermolecular forces abstract or resist the layers from slipping over one another, resulting in a friction between the successive layers. Hence, viscosity is a force of friction. Viscosity is nothing but it is the force of friction between the successive layers of a flowing liquid. Viscosity is also the resistance to the flow of a liquid. Remember that. Viscosity is nothing but it is the resistance to flow of a liquid. So, it is also the resistance to flow of a liquid. When a liquid flows through a tube, the central layer has the highest velocity. This central layer has the highest velocity when the liquid flows through the tube or pipe. The central layer has the highest velocity, whereas the layer along the inner wall of the tube, in the tube remains stationary. I told you these layers which are in the inner wall of the tube remain stationary, and this is the result of the viscosity of a liquid, and that is why this, due to the stationary layers which have less velocity, due to that the property viscosity is there in the liquid. Remember that. Hence, a velocity gradient always exists across the cross section of the tube. These are the velocity gradients. Different velocities are there. As we go away from the central layer of the tube of the liquid which is flowing into that tube, their velocity decreases and decreases towards the wall. And this is the velocity gradient that is exists across the cross section of the tube or pipe. Viscosity also depends upon the molecular size and shape of the molecules also. Spherical shapes have more, that is the viscosity. And the molecules which have the larger molecules, which have the larger shape, have the more viscosity. That means they, such liquid in which there are the larger molecules, they have the large viscosity, and due to that they flow very slowly. That means the viscosity, greater the viscosity, slower is the flow of the liquid. Remember that. Another factor which depends or affects the viscosity is the temperature. Now, viscosity is inversely proportional to temperature. That means viscosity is a temperature dependent property. As temperature increases, viscosity decreases and the liquid flow fastly. But if there is the large viscous liquid or the viscosity is large, then the rate of flow of liquid decreases, or the liquid flow with a less rate. Remember that. That means the liquid flow slowly. Now let us learn the unit of the viscosity. In which unit this viscosity is measured, because viscosity is also the quantitative property of the liquid. Now let us learn about the unit of the viscosity, and again some that are the what are the effects due to this viscosity. Now let us learn the unit of viscosity. Now viscosity is expressed in terms of coefficient of viscosity. Viscosity is always expressed in the terms of coefficient of viscosity, and it is denoted by eta. Now this is the sign which is called as eta. It is defined as, eta is defined as, that unit of viscosity, that is the coefficient of viscosity, is defined as the degree to which a fluid resists to flow under an applied force, which is measured by the tangential friction force per unit area per unit velocity gradient when the flow is a laminar flow. Now SI unit of viscosity coefficient is Newton second per meter square. Newton second per meter square is the SI unit of viscosity, and in CJ system the unit is measured in poise. Now 1 poise is equal to 1 gram per centimeter per second, or 10 raised to minus 1 kilogram per meter per second. Now 1 gram is equal to 10 raised to minus 1 kilogram, we know that, and therefore these are the unit in the CJ system. Now what are the illustration of this viscosity or applications of this viscosity? Now in the lubricating oils, you know the lubricating oils are very viscous liquids. Gradation of lubricating oil is done on the basis of viscosity. Which lubricating oils are more useful? This gradation is done on the viscosity, on the basis of the viscosity of these lubricating oils. A good quality lubricating oil does not change its viscosity with increase or decrease in temperature, though the temperature increases or decreases. But if the viscosity of the lubricating oil does not decrease, then it is the good quality lubricating oil. Now second one, that is the indication of cardiovascular disease. This is also due to the viscosity of the blood. Now we know that the increased blood viscosity than the normal value is taken as an indication of the cardiovascular disease. If the viscosity of the blood increases, then that is the indication of cardiovascular disease, that is the heart attack, etc. Now third one is the glass pans of the old buildings, that is the glass pans of the old buildings, of their doors or of their windows, pans, these glass pans of the old buildings are found to become thicker and thicker with time near the bottom, and this is an evidence which indicates that the glass is not a solid but it is the super cooled viscous liquid. Now when you see that is the windows of the old buildings and the glass pans of that windows, they are somewhat thicker at the bottom and thinner at the upper side. Now this is due to the viscosity of flow of that glass, because glass is not solid but it is the super cooled viscous liquid. Remember that. And as the time passes, after so many years, the glass flows slowly and slowly to the bottom, and the bottom of the glass pans becomes thicker than the upper side of the glass pans. Now this is the about the viscosity. Now this is the end of this chapter. You may that is write the exercise and questions of this chapter. So students, if you understand these properties of the liquid, that is the surface tension and viscosity in details, then you can share, you can subscribe and like this video and tell the other students which are another college students of 11th science also to like, share and to watch this video. This is very important video. Thank you.